Progress in electrical distribution tends to be slow and steady. Electrical infrastructure like breakers and transformers have all been steadily improving since they were invented, and even things like enclosures have become safer over time. On the other hand, traditional cable and conduit haven't changed much due to their simplicity and straightforward purpose. Since the discovery of electricity, wires have served their purpose in routing power from point A to point B with very little need for improvement. However, modern-day power systems see much more load fluctuation, have higher energy demands, and require more complex configuration. In these situations, Busway, also called bus duct, has many key advantages over traditional cable and conduit. In this video, we'll explain in detail what Busway is, how exactly it works, and then discuss some broad examples where using Busway can streamline installations, reduce costs, and enhance the overall performance of electrical systems in a wide variety of industries. Here's a piece of Busway. Every piece has three main elements: conductors, insulation, and housing. The conductors are made out of rigid bus bar instead of flexible cabling. This is where the bus in Busway comes from. Just like normal wire, the metal can be copper for higher current capacity or aluminum for lighter weight. Making the conductors bars instead of wires gives Busway all of its key advantages, which we'll touch on in just a second. Busway is used in three-phase applications, so each piece will have three phase bars and may include a fourth bar for a neutral if required. Each of these will be insulated so that they can be brought closely together. One particular advantage of having a rigid conductor is that the insulation isn't required to be flexible. This enables the use of stronger dielectrics such as polyester tape or fiberglass that wouldn't be suitable for wiring. At Eaton, our Busway uses an epoxy that has a strength of over 20 kV per millimeter, which is significantly stronger than any cable insulation for a given thickness. Additionally, epoxy can be applied as a liquid, making it form-fitting for any shape. All of this helps shrink down the final product to as compact a form factor as possible without sacrificing any electrical integrity. The last part of the assembly is the housing, which ties all of the bus bars together into one package. Aluminum is generally used since it's robust, lightweight, and easily machinable, but it may also be steel for more heavy-duty applications. In either case, though, the housing is made from metal, which allows for several grounding options: integral grounding through the housing with no extra conductor, a dedicated ground bus bonded to the housing, or a fully isolated ground bar. Altogether, this is one unit of Busway. Whereas wire comes in large spools, Busway comes as modular pieces that can be connected together, like building blocks. There are straight pieces and connectors like 90s and Ts that can be strung together to easily form complex networks in one continuous piece rather than needing to run separate cable feeds. One of the main benefits is the reduction in space requirements for high ampacity systems. Now, like any electrical connection, proper torque is required to prevent loose connections, heat, and ultimately the risk of damage, so special care is made to ensure that pieces connect securely and safely. Here's what's required to install a 5,000 amp feed with traditional cable and conduit. There's no single wire that can handle that much current, so it needs to be split into multiple bundles, each with its own run of conduit. Each run then needs to be supported somehow, and the entire assembly ends up requiring tons of support infrastructure throughout the entirety of its length. Now look at the same 5,000 amp feed with Busway. The entire thing can be supported with two parallel runs, which takes a lot less space and is easier to support. Now before we go into different types of Busway, let's take a closer look at the bar conductors again to see how Busway works. The rectangular shape that you see does far more than making the bus more easily stackable. It also brings about important electrical benefits. Here's the cross-section of a standard cable versus a bus bar. Typically, when we imagine current flowing through a conductor, we assume a uniform charge distribution. However, this is only true for direct current. For alternating current, electrical eddy currents will actually push charge to the outside of the conductor. This is known as the skin effect and can play a big role in cable design at all power levels. Now in our case, this doesn't matter too much for small conductors, but as we begin to increase in size, simple geometry tells us that the area to perimeter ratio increases much faster for circles than it does for tall rectangles. Electrically speaking, this means that traditional cable will have more effective resistance at its center than busbar. The skin effect, coupled with the proximity effect that arises with multiple smaller conductors, results in an underutilized region of metal at the center that decreases overall thermal performance, which in turn ultimately dictates the amperage rating for a conductor. So in short, this skinny rectangular shape both helps reduce voltage drop and increases ampacity rating by about 15% for the same amount of metal, making power distribution both more reliable and more efficient. Now, all busway will work the same way electrically, but it might come in different forms depending on the application. Each type has its own connections and options that optimize it for one environment over another. There are three main types: sandwich, track, and non-segregated phase bus. Sandwich-style busway adopted the name due to the phase bars being stacked or sandwiched on top of each other throughout the busway enclosure. As discussed previously, the insulation on the bus bars allows for phases to be stacked without risk of fault. This type of busway can be indoor, sprinkler-proof, or outdoor rated, and is available as either feeder or plug-in, and typically comes in 10-foot lengths and are connected with breakaway bolts to ensure proper torque. Feeder busway are straight-length pieces that are purely used to bring power from point A to point B. Plug-in pieces, on the other hand, can do the same while also allowing for tap-offs every 2 feet in between front and back. At these locations, bus plugs can be installed to feed loads below. The cable feed coming into the busway is terminated at a cable tap box, which then transitions to the first piece of busway. Eaton's PowerWay 3 sandwich-style busway is available in either copper or aluminum bus bars with configurations from 225 amps up to 5,000, and either option will have tin or silver-plated contact surfaces depending on specification. PowerWay 3 is considered low voltage and can be applied to any system rated up to 600 volts. It's suitable for any facility with high power requirements and many loads, like data center gray spaces, industrial facilities, high-rises, hospitals, manufacturing, or other environments that change over time. For example, automotive manufacturing lines tend to be reconfigured for new models every 5 years, and busway allows for flexibility without a full rewire every time. Track-style busway doesn't use bus plugs. Instead, it uses tap-off boxes that can be placed nearly anywhere along the busway system thanks to its continuous power rails. The equivalent of the cable tap box for this type of busway is called an end feed, where the incoming cable transitions to busway. Eaton's PowerWave 2 track busway is available from 250 amps up to 1200 amps to support systems rated for 600 volts or less. Typical applications for track busway include data center white spaces, laboratories, warehouses, and other light commercial applications where loads are continuously being changed out, moved, or expanded. The third type of busway is called non-segregated phase bus and is equipped with copper or aluminum phase bars located in one enclosure, separated by both epoxy and air insulation. Non-segregated phase bus can be rated for low voltage applications as well as medium voltage up to 38 kV. Amperage options range from 1200 amps to 6000 amps, and this style is available with a variety of insulating supports. Environmental ratings include indoor, outdoor, and dust tight, and housing material can vary from aluminum, steel, or stainless steel, making this the perfect busway solution for harsh environments such as oil and gas or other hazardous work sites. You'll see non-seg bus between outdoor transformers and switchgear or switchgear to switchgear lineups. With any busway application, standard increments and customized pieces can be ordered to meet almost any length requirement. Bus plugs or tap-off boxes were briefly mentioned before, but here's a little more detail. They connect into the busway phase bars to distribute power to the actual loads, and they can come equipped with either circuit breakers or fuses for ratings anywhere between 15 amps and 1200 amps. Typical fuse interrupt ratings are 200 kAIC, and breakers range from 10 to 200 kAIC depending on the voltage. Like the busway itself, bus plugs are available with a variety of ground and neutral options, and they come in multiple configurations for different style busway. Standard bus plugs or tap-off boxes come with mechanical lugs included for cabling to equipment. For data center applications, receptacles are available as either single, double, or quad plug-in arrangements as fixed-mounted or cord-mounted. Additionally, other auxiliary equipment, such as metering or communication equipment, can be integrated directly into the box for purposes like branch circuit monitoring. After all, it is a box, and you can fit a lot of things in it, even EV chargers. So now that we've gone over a couple different options for busway, let's compare the installation process directly against cable and conduit for two prospective sites, a hospital laboratory and a commercial skyscraper. While busway certainly does have electrical benefits, installation is actually where we're going to see the main benefit, in the time and labor saved to get a new system running and making any modifications afterwards. Let's say we want to provide power to this hospital lab. The main incoming feed is fed from the top, and there are plans to install equipment along the perimeter and possibly the center. For our conduit and cable system, first we're going to need a switchboard to split up the incoming power. Since there are plans for expansion, we can leave provisions in the switchboard for extra breaker spaces, but if we misjudge it, then we'll need a second structure somewhere. Now, if there are plans for where the equipment goes, we can proceed to run conduit out of the switchboard to its destination according to the blueprints. Conduit will often need to be custom bent to odd angles and around corners to dodge existing infrastructure, then requires proper mounting and securing all along its length. Finally, cable can be pulled through. However, depending on its size and length, this alone may be an extremely difficult and involved process. This conduit and cable installation procedure then needs to be repeated for every additional piece of equipment, with each run having less and less space and needing to dodge previous ones. It can be a major challenge to just plan out every cable and conduit home run. Hopefully, if the work is done cleanly enough, making modifications to the system in the future won't be too cumbersome. This sort of process requires meticulous planning and takes a long time to be executed well, and even then, unexpected complications might arise that can cause massive headaches. Now, let's compare it to a busway installation. Since we're going to have circuit protection in each plug, there's no need for a switchboard. Instead, we can go ahead and land the main incoming directly onto the lugs of a cable tap box or end feed, which will break out directly into busway. From here, all we need are standard lengths of busway to cover all of our bases. If we use Power Wave 2-track busway, then tap-off boxes can be placed directly above wherever we want power. In terms of modification, equipment can be moved or added without regard for previous drops, so long as the total busway amperage isn't exceeded. This installation requires far less planning, uses far less material, takes far less time, and comes future-proofed out of the box. Now for our second site, let's look at a commercial high-rise fed from basement switchgear. Instead of running conductors all around a room, the new challenge is to run it all vertically to a panel board on each floor. For a building that's several stories high, it isn't much of a problem to run a couple feeds through an elevator shaft. But the taller the building is, think 20, 30, or even more floors, the more cable pulls have to be made, the more space you take up, and the higher the risk there is for problems to occur, like accidentally dropping heavy cable back down from the top. Again, especially depending on the amperage required and size and number of cables being pulled, this is a very time and labor intensive process that can multiply very quickly. If we do the installation with busway, instead of running a home run from the basement to each floor, we can simply tap off the busway at each floor, drastically reducing the installation materials and labor. Think of it like using a 480 volt power strip for your entire building. Using sandwich style plug-in busway like Power Wave 3, all that's left to do is install a plug on each floor and connect it to the panel board. In fact, this is very similar to how low voltage power is delivered in the world's current tallest building, the Burj Khalifa. The Burj Khalifa is over 2,700 feet tall and relies on about 5 miles of vertical Power Wave 3 busway to distribute electricity to each of its floors. Busway offers many benefits in today's dynamic environment. Cost savings, space savings, configurability, and efficiency are all reasons why busway is being used in modern facilities and applications like megascale data centers, manufacturing plants, and EV fleet charging bays. To learn more about busway and how it can be used in your installation, visit eaton.com/busway or contact your local Eaton representative to schedule a visit to one of Eaton's Power Systems Experience Centers today.